Okay, so the next part of this section, we're talking about slope-intercept form. So whenever we have an equation that is in a certain form, or in this case, it'll look something like this. Y equals mx plus b. Now, the two variables that'll change, depending on your equation, are the variables m and b. So, if we look at example A to start, our m value is actually 2, because that's the number that's in front of our x variable. And then our b variable is represented by -4. So, the nice thing about this form is we don't have to do any work to figure out what our slope is and what our y-intercept is. And if you don't remember, slope is represented by the letter m. So where it says m equals and then a blank, they're asking us for the slope. So for example A, our slope is going to be the number that is being multiplied by x. So in this case, that number is 2. And I don't mean to write with a highlighter. That looks better. So m equals 2. That is our slope. We might also represent that as a fraction where it's 2 divided by 1. Because notice 2 divided by 1 still equals 2. But this allows us to use the rise over run method, which I'm guessing some of you have heard of. So I'll talk about that once we graph this. But that's our slope. Our y-intercept. Now this one, the y-intercept value is -4. However, the y-intercept is just the point on our graph where our line crosses the y-axis. So the y-axis is this vertical axis here. So what we're trying to figure out is, let's say I had a line right here. Okay, so then the y-intercept is wherever my line crosses this y-axis. So for this line, it would be right there. So because of that, our y-intercept, we are going to label it as a point. So remember, our points on a graph, we label them as what's called an ordered pair. That's where we have a parenthesis, and we have some number that represents the x value and some number that represents the y value. So for example, if I decided to put a point right here on the graph, actually that's not a good one. Let's go right here. So that blue dot, that point would be represented as my x value being 2, because our x value is looking at the horizontal numbers. So in this case, 2 is how far over I need to go to get to the blue dot. So that would be my x value. And then my y value is how much I change up or down. So in this case, that would be just up 1. So my y value would be +1. So that's just a quick review on how we use a dot or a point on a graph and represent it as an ordered pair like this. So with all of that being said, I'm gonna erase all of this because we don't need any of that anymore. And now we are going to actually figure out the y-intercept for this equation. So I said the y value is -4, but we need this as an ordered pair, so I need to figure out what's my x value gonna be. Well, there's actually a really easy solution to this. For any y-intercept, the x value is always 0. The reason that is because notice, x gets bigger as I go to the right. So this is x equals 0. Then this is x equals 1. This is x equals 2, 3, 4, and so on. If I go to the left, my numbers are just negative, so they're getting smaller. So I have -1, x equals -2, x equals -3, etc. It keeps going. So when x is right here, it equals 0. But notice it's going to be 0 anywhere along the y-axis. Because if I'm just on the y-axis, I'm not going to the right or to the left. So my x value will never change. So for the y-intercept in any equation or for any line, your x value will always be 0. Okay, so now that we have all this information, how do we actually graph it? You start with your y-intercept. So that point, 0, -4, we wouldn't move left or right on our graph. but when our y value is -4, starting at the origin, we would just go down 4 units, and this is exactly where our y-intercept would be. So I'm going to mark that with a dot. Now, to get the rest of the graph, we are going to use our slope. So I wrote it as 2/1 because I said we can think of it as what we called rise over run. Now, this is helpful because from any point on a graph, if we think about rise over run, my numerator, in this case, 2, is the rise. So that's how many units I'm going to shift vertically. So +2 would mean I'm going from this point up 2 units. That would be my rise. And then my run is whatever number is in the denominator. In this case, it's +1. So after I use my rise to go up 2, I would go +1, which would be right 1. And so my next dot for the line is going to go right there. So I'm going to go ahead and put a dot there. Now, to get an accurate graph, let's put one more point on here. So I'm just going to use the rise over run method one more time. So from this new dot, I will go up 2 and right 1. So my new dot will go right there. Now that I have 3 dots, I'm going to do my best to draw a line through them. Doesn't have to be perfect. And that is the graph for the equation y equals 2x minus 4. Okay, so we start with the y-intercept, we graph it, then we use our slope and use the rise over run method to get 2 more points, draw our line. All right, let's go ahead and try this in another example. So this is very similar to the previous problem we did. The biggest difference is our slope is now a fraction. So that doesn't change things a whole lot, but it will change slightly how we approach this. So finding our m and our y-intercept. So our m, you remember we said is the number right in front of x. In this case, we have to include that negative sign because that's important with the slope. So our slope for this is actually negative, man, I keep sticking on my highlighter, -2/3, or -2 divided by 3. And then our y-intercept, I think I used green for that on the last problem. So our y-intercept is whatever this number at the very end of our equation is. So in this case, it is 5, but remember, we want to list it as an ordered pair. So we need those parentheses, and our x value is always 0 for the y-intercept. So now I have my information, let's graph it. Starting with the y-intercept of 0, 5, that means I will just go up 5 units since it's a +5. So my y-intercept is going to be right there. Made it nice and big. Then we're going to use our slope of -2/3 to get a couple more points. So because it's -2/3, that means from this point, I'm going to go -2 as my rise, because -2 is in the numerator. So -2 would be down 2 units. And then my run is +3 in the denominator. So we went down 2, and then we're going to go right 3 units. So that is where my slope will take me for the next point. So down 2, right 3. Notice, I'm going to show you something. I could have also written this as +2 over -3. Now, what does that do? Well, let's go, oops, I think I just erased my 3. +2 over -3. So let's start at our same point again, that y-intercept. And now let's try this slope and see what happens. Well, let's say +2 as a rise, that would mean I'm going up 2, okay? So I just did the opposite of what I did the last one. I went down 2 for that one, but now I'm going up 2. And then also, the denominator, instead of being +3, is -3. So instead of going down 2 and right 3, I'm doing the opposite. I'm going up 2 and left 3. So let's put a dot there. Let's see what happens. All right, I'm going to go ahead and draw a line through those. Oopsies. Now check this out. If I would have kept going, so originally I went down 2 and right 3. Let's see what happens if I would have done that again. Down 2, right 3. Well, it looks like my line wasn't perfectly straight, but it should have gone straight through that point as well. So if you have a negative slope, just make sure the negative sign is either in the numerator or in the denominator. So it can either be negative 2 over 3 or 2 over negative 3. And as long as you follow your directions correctly, it will be on this line no matter what. The only mistake you might make, and you need to be careful of this, don't put a negative 2 and a negative 3, because that actually is a positive slope. So if there's ever a negative sign with your slope, just choose either put it in the numerator or the denominator, and your line should be okay. So that is our final graph for B. I want you to look at C, identify what your slope and your y-intercepts are, and then build a graph. So go ahead and pause the video, work on that, and then once you're done, unpause and see if you got what I got. All right, so I got my slope to be 1, my y-intercept is the ordered pair 0, 1, and my line is on the graph. So if you got something different, check and see if you made a mistake somewhere. All right, last one on this page, problem D. Our slope, if we take a look, that number in front of x is 1/4. 1/4. And our y-intercept value, well, the y value at the y-intercept is -2. So the y-intercept is 0, -2. Graphing this now, my y-intercept, 0, -2, is going to be right there. And then if I think of my slope of 1/4 as rise over run, I would go from this point up 1, right 4. So I'm going to put another point there. And then I'll do the same thing again from this new point, up 1, right 4. And I got another point right there. And then I'm gonna try and draw a line. And as long as I kind of get it through the points, we should be good. All right, going down to the last page of this section, we have a few more graphs. Some of these are gonna be interesting. So let's look at E. What do you think my slope is for this equation? You can pause the video if you want and kind of think about it, but all I have is a negative in front of the x. If you remember from the last section, we said that if we ever have the term x, we can think of it as 1 times x. Well, in a similar way, if I ever have the term negative x, I can think of it as -1 times x. So if I have a negative sign in front of my x, and we're talking about the slope of this line, because it's an equation, my slope is actually going to be -1. You can also think of it as -1 divided by 1, if we're going to use rise over run. So that's the interesting thing about this one. The y-intercept is pretty straightforward, I think. We have -4 as the value, so the y-intercept will be 0, -4. So now if we want to graph this, our y-intercept at 0, -4 is going to be down there on our graph. Now, to use my slope of -1, I will go from this point, and we said the slope could also be written as -1 divided by 1, so that would be down 1, right 1. So I'll go ahead and put a point there, and then we can do that again, down 1, right 1. That point will go right there. I got 3 points, that's enough. I'll draw my line, maybe. And there we go. So we have a negative slope in this graph. Take a look at graph F. This one's very strange because it looks like we're missing something, but actually we're not, and this isn't going to be too hard to graph. So let's start with slope. I think we can figure this out. So our slope is whatever's in front of x. Well, I don't see anything in front of x, but we just said if we ever have the variable x, that is the same thing as 1 times x. So I can assume there's this little invisible 1 here, so that means my slope is just going to be 1. That's not too bad. Now, what's my y-intercept? Because I don't see anything over here. There's nothing there. Well, if there's nothing there, our y-intercept is actually just going to be 0. So our x value has always been 0 for y-intercepts, but in this case, the y value is also going to be 0. Because notice, I could just add that in. I could say, oh, this whole equation and then plus 0, because if I add 0 to anything, I don't change its value. So our y-intercept for this equation is 0, 0. And you might remember the point 0, 0 on our graph, also known as the origin, is just the very center of the graph. It's actually where the x and y axis intersect. So this graph, the y-intercept is at the origin, and our slope is 1. So that means I'm going to go up 1, right 1. I'll do that again, up 1, right 1. I'll draw another point. And so our graph should look something like this. So if you don't ever see a number in place of where we find the y-intercept in a graph, that just means that it is probably 0. Okay, 2 more. This one's even weirder. Take a second, try and figure out what's missing. There's no variable x. So all of our other graphs, we have that variable x in there, and that tells us what our slope is, because whatever number is being multiplied by x, that's what our slope is. But this graph, there's no x variable. So what does that mean? Well, kind of like the last equation where I said there's no y-intercept value, but we can think of it as plus 0. In this case, there's no x value, but I could think about changing this to y equals -4 plus 0x. Because if I take the number 0 and I multiply it by x, well, 0 times anything just equals 0. So if we think about it like that, and our slope is the number that we multiply by x, well, if there is no x in our equation, then that means we're multiplying x by 0. So our slope for this equation is going to be 0. And then our y-intercept for this equation, again, it's the part of the equation, or it's the number in the equation on the same side as x, but it's not being multiplied by x. So in this case, it is the -4. So our y-intercept is going to be 0, -4. Taking this to our graph, our y-intercept at 0, -4, put that down there. Now, what do we do when our slope is 0? Well, we just draw a horizontal line. So, if our slope is 0, we can think of this as, it's just a horizontal line. And the other interesting thing about this is I can pick out any point on this graph. Let's say I went here, where that little red dot is. Okay, well, that is actually the point. If we trace our spots, x equals 4 and y equals -4. Okay, so that would be the ordered pair 4, -4. Okay, I'm going to pick out another point. Let's go over here on the left side. What would this point be? Well, my x value is -6. So I know my ordered pair will start with -6, because that's the x value. And then I go down to -4 again. So my y value is again -4. So notice, if I look at all these ordered pairs, my y value is -4 here, it's -4 here. We know at this dot here, the y value is also -4. What was our equation again? It was y equals -4. So our graph for a line where it's just y equal to some number, every single point on that line, the y value should be equal to whatever that number is. So that's a way you can check and see if you got the correct graph. Okay, one more, and then we are done with this page. We have x equals 5. Okay, this is even weirder. We don't even have a y value. So how do we figure out our slope and our y-intercept? Well, similar to this graph where we had y equal to a number, and we said, oh, okay, well, where does y equal -4? Well, we have to go down 4. So we just drew a line through -4 on the y-axis. In a similar way, let's think about, okay, if x equals +5, let's look at our graph and figure out where does x equal +5? Well, we would have to go to the right 5 units, right? So we know this part, x equals 5. But then if I draw a vertical line, oops, let me go back to blue. If I draw a vertical line through that point where I know x equals 5, then any of these points on this graph, x should also equal 5. So, as far as filling out this information up here, if x is ever equal to a number, our slope for that is undefined. Okay? So there is no slope. And then for our y-intercept, since we're drawing a vertical line, it's actually never going to cross the y-axis because the y-axis is also a vertical line. So for our y-intercept, there is none. So we'll talk more about those in some worksheets, but you won't see those too often. That's a pretty rare graph that you'll see. Most of them are going to look like what we did up here on this first page when it comes to slope-intercept form.